Hello everyone. Today I am going to explain question number 15 from miscellaneous exercise of chapter 7 from 12th class maths. So chapter 7 is based on differentiation. Now in question number 15, first we will solve the A part. In A part, if y equal to e to the power ax multiplied by sine bx is given to us, then we have to prove d square y upon dx square minus 2a dy over dx plus bracket a square plus b square bracket close multiplied by y is equal to 0. So this relation we have to prove. So if to prove this relation, whatever we need, first we'll find out that. So the first term is the second order derivative of the given function, and then in second term we need the first order derivative. That's it. Other remaining things are available already. So the conclusion is, first we have to find out the dy over dx, and then we have to find out d square y over dx square. So we'll proceed the solution. Here first I wrote what is y given to us. Now since we want dy over dx, that's why we have to differentiate the given function with respect to x. That's why here I obtained dy over dx. Now when we'll differentiate this right hand side, the right hand side is the product of two functions. Two functions are e to the power ax and sine bx. So when we have to differentiate two functions product, that time we are going to use the formula u dot v. In that, first we have to keep one function as it is and differentiation of other function. Like this we have to proceed. So here first I kept this e to the power ax as it is and I differentiated sine bx, and in second term I kept sine bx as it is and I differentiated e to the power ax. Now in next step, this e to the power ax as it is I wrote. Now when we differentiate sine bx, sine differentiation is cos x, that's why sine bx differentiation is cos bx, but we have to apply the chain rule, and according to the chain rule we have to differentiate this bx again. So when we differentiate this bx, the answer will come b. In the same way, in the next term, sine bx I wrote as it is. Then we have to differentiate e to the power ax, and students, we know that e to the power x differentiation is e to the power x only. That's why e to the power ax differentiation is e to the power ax, but we have to apply the chain rule. So we have to differentiate this ax again. So when we differentiate this ax differentiation is only a. Now this is our first order derivative. Now from here you can see that e to the power ax is present in both the terms. So that I took common. So like this I obtained my dy over dx. Now since we want the second order derivative also, that's why this dy over dx equation, that is equation second, will differentiate again with respect to x. That will give us the second order derivative. So when we differentiate, in the left side we will get the second order derivative, and in right side again it is the product of two functions. This is our first function and this complete big bracket is our second function. So first I kept e to the power ax as it is and I differentiated this big bracket. Then in next term, big bracket I kept as it is and I differentiated e to the power ax. Now in next step we will do the differentiation. So e to the power ax I kept as it is. Now when we differentiate this, this differentiation will distribute to both the terms when we open the bracket. The conclusion is we have to differentiate b cos bx also and a sin bx also. So when we differentiate b cos bx, first since this is a multiplication, it is in b is in multiplication with cos bx, so b will behave as the coefficient. So b I wrote as it is. Sin bx differentiation is minus sin bx, and then this bx differentiation again we have to do. That's why b came in the multiplication according to the chain rule. Again this a as it is, sin bx differentiation is cos bx, and this bx again we have to differentiate, so that will give us b. Now this big bracket I wrote here as it is, and ax differentiation is e to the power ax, and ax differentiation according to the chain rule is a. Now here I opened all the brackets and I obtained this. Now here we can see that this first term, this one and the last term are in that many things are common. So I took e to the power ax sin bx common. So I obtained in the bracket from here a square and from here b square. Now the second term and third term are same. So I added them. That gave 2ab e to the power ax and cos bs. So this is our second order derivative. Now we'll proceed towards what we have to prove. We have to prove this relation. So in left hand side, first I wrote the left hand side, and in left hand side we'll substitute the values from equation 1, 2 and 3. First on replacing the values from equation 1, 2 and 3. So we'll simply substitute the values from these equations. The values which you are going to substitute is of second order derivative, then first order derivative multiplied by minus 2a, and then y value also will distribute. Now we'll open the brackets. All brackets is open. So when we'll open all the bracket, what we found is many terms are like and with opposite signs, so they will cancel each other. Now here this a to the power, this term, that is a square, and one more a square is there here, a square e to the power x and b. So these two will get add. So we'll get positive 2a square and this term. Now finally they will also get cancelled and we'll get 0 answer. So this after open the bracket, simple plus minus is there that you can do by your own self. And after doing all these things carefully, you will get 0 answer. That is our right hand side. Hence we proved that left hand side is equal to right hand side. So students, this question is not so tough. What we had done is, whatever be the given function, from that given function we calculated the first order derivative, then second order derivative, and then in required equation we had substituted the values, and then simply we had opened all the brackets and we had done plus minus, and hence we got the result. Now we'll move to the B part of same question. In B part, again y is given to us and we have to prove this relation. And here students, y2 means second order derivative and y1 means first order derivative. So conclusion is, we want the first order derivative also and the second order derivative also. So first I wrote the given function, and since given function is in terms of x, that's why we have to differentiate with respect to x. So when we differentiate this y with respect to x, here we will obtain dy over dx, and since it's a fraction, so we are going to use fraction formula. In fraction formula, what's fraction formula? Denominator square, then denominator as it is, numerator differentiation, then numerator as with minus sign, numerator as it is, and then denominator differentiation. I hope since it's the end of the chapter, so I hope the fraction differentiation is clear to you. So again I am repeating here, whenever we have to differentiate any fraction, we have to use the fraction differentiation formula, that is denominator square down and the denominator as it is, and first we have to differentiate the numerator, then minus sign, and numerator keep as it is, and then denominator differentiation. So now we will proceed the differentiation. So here in denominator, when we will do the square, root and square will cancel each other, so that's why we will obtain here 1 minus x square. Now this root 1 minus x square as it is, we have to differentiate sin inverse x. Direct formula is available, that is 1 upon root 1 minus x square, then minus sin inverse x. Now this denominator, that is root 1 minus x square, I wrote in the power form so that I can use the formula x to the power n differentiation, that is n x n minus 1. So when we will do this n x n minus 1, n is half, and then n minus 1 when we will do, so we have to do half minus 1. So when we will do half minus 1, that will give us minus half. Minus half means we have to shift in the denominator and with root sign. Again I am repeating, when we will apply here x to the power n formula, we will get here minus half power, and minus half power means we have to shift in the denominator with root symbol. Then again we have to apply the chain rule in the bracket. So when we use the chain rule in the bracket, one differentiation is 0 and minus x square differentiation is minus 2x. Now we will simplify it in next step. Here these two terms are same, so they will cancel each other, so only one will remain here. Now this minus sign and this minus sign will multiply each other, so minus minus plus, and 2 and 2 will cancel, so we will obtain like this. This x I shifted in front. So when we will observe it carefully, what we will find is sin inverse x and root 1 minus x square is our given function. So this given function, we will see y is equal to sine inverse x upon root 1 minus x square is given to us. So this complete term will replace by y, and this is in division, so it will shift here and it will come in the multiplication. So this step is very crucial, because without replacing it by y, if we will proceed, it's going to be very complicated. That's why don't do like this. Here replace it by y. Then now after replacing it by y, we will differentiate it again with respect to us to get the second order derivative. So here when we differentiate, again it's a two function. First function is 1 minus x square. The second function is dy over dx itself. So when we differentiate, first I kept this bracket as it is and I differentiated this derivative symbol. That's why we got second order derivative. The second time I differentiated this bracket. So when we differentiate this bracket, one differentiation is 0 and x square differentiation is minus 2x and dy over dx as it is. And here when we differentiate, one differentiation is 0 and again it's a product of two functions. So first I differentiated y, then I differentiated x, so x differentiation is 1. Now from here, this I kept as it is. Now this is a negative, so I shifted in the right hand side, sign changed, other things I wrote as it is. So this x and this 2x will get add, so it's going to be 3x dy over dx. Now to bring our result, the second order derivative I replaced by y2 and first order derivative I replaced by y1. So this is our required result. We obtained our answer. So I hope both the parts of question number 15 is clear to you. And if you have any problem, you can write in comments so that I can explain again. Unless both questions are very simple. But take care in the B part that after obtaining the first order derivative, you have to replace sine inverse x upon root 1 minus x square by y. That's very important step. Okay. Thank you.